So, all right, that'll do. 3, 2, 1. So we should have in front of us these graphs, and you've probably got no idea why I've made you draw these graphs. What can you tell me about this point here? What is that? 2 pi, or assume we're dealing with radians here. And this point here? 2 pi. Exactly 1 period after we start, correct? That would make this point here. And this point here. Pi on 2, and this point here. And the same would apply for this one, correct? So your graph should look something like that. And the topic we're dealing with today is derivatives of trig functions. What can you tell about trig functions? Tell me something that you know about trig functions. They repeat. They repeat over their period, correct? What's the biggest value this function will ever equal? What's the smallest value this function will ever equal? -1. What value does it hit in the middle of those? 0. Sweet. This function here is y equals sine x. Now I want to derive that, but before we go through how we derive that, I want you to use your straight object to point out some key points. The first points I want you to identify is when is the derivative function 0? So how would you know when your derivative function is 0?
When y equals 0?
Not quite. Remember, I got you to get something out, correct? What did I get you to get out? The ruler. So what I want you to do with your ruler is just trace over it like that as you're going through. And then I want you to tell me when you think the derivative equals 0 for that function. Circle it on your graph. Where do you think the derivative equals 0? When do we get a derivative of 0? When we have a min or a max, correct? That occurs when our gradient is? What's the gradient of this ruler right now? 0. Horizontal line, correct? So what I'm really getting you to do is trace your graph and look for horizontal lines. Circle any point in time where your gradient, your derivative, your tangent, has a horizontal line. Do it on both graphs, please. I'm hoping that you identified this point here and this point here. So on that graph that you've got, I want you to use a different coloured pen or a dashed line and just put a circle at those points. Now, what I want you to do is to identify the point where you think the gradient is at its highest. So I'll just say that again. When you think the gradient is at its highest. So I want you to trace through your trig graph here and identify the point where you think the gradient is the highest. So which way should it be pointing? As close to vertical as possible, correct? Should it go this way? Should it go this way? We want it positive. So if we can't get it vertical, which I doubt we're not going to get it vertical, correct? Not in this graph. But we might get it pretty steep. So identify the point in time where we're pointing to the top right-hand corner as steep as possible. And again, just circle that point on the graph. Just put a little mark at it.
On both sides?
On both graphs, please, yes. Ryan, where do you find your highest point for your sine graph? At pi, you found your highest point? I think you found a key point, but I don't think it's your highest. Because I'm going to ask you, we want the ruler pointing in this direction, correct? So if I put that there, but you found something, you found the next question, that's the steepest point, it equals in the other direction, but that's one question in front. Jerry?
On the side one, the highest outcome was ever
At
at 0.
0. Yep. Does it happen anywhere else?
Yeah, so
2 pi. So, what I want you to do is in line with your highest value, put a dot at 0 on your sine graph, and you said 2 pi?
Yep.
A dot at this point here. For your cos graph, I haven't filled it out, I'll leave that up for you. I want you to do the same thing, but try and find the highest point. I'll fill that out afterwards because I don't want to give away too many secrets. Once you've done that, as Ryan has suggested, I want you to find your lowest gradient. Now, I don't mean your flattest gradient, I want your most negative gradient. So Ryan, where's the most negative gradient occur? At pi, very good. Where else do you reckon? So what do you think would happen at 5 pi on 2? What do you reckon would happen at 5 pi on 2? Just have a guess. 0 again? What about at 3 pi? Okay. Now, don't use a straight line because trig functions, if we were thinking about the gradient of this line, there's never a jagged point, is there? It's always curving and moving around as we go through. So I want you to connect these with curved lines. Like so. And then tell me what it looks like. So what does that tell you about the derivative of sine theta, or sine x? The derivative of sine x equals cos x. Very good.